Hey there, pre-calc. We are in 4-1 still. We're finally going to finish this thing up, and you see, hopefully you notice why we're going to try and break this thing apart as much as we can for you. Been a lot of factor label in each part. I have a bunch of stuff typed in here, so totally however you want to handle that for your notes then. All right, so the linear velocity, that's the rate an object travels in a linear path in a unit of time. Okay, so I have some examples down here, right? Miles per hour, this is what we're used to. Feet per second, you use that in physics and science class, maybe inches per minute. Those are just some examples, not all of them. Okay, and how that changes when we start talking about angular velocity, that's the rate an object moves in a circular path in a unit of time. Okay, so most notably is going to be revolutions per minute, right? So if you're into cars and stuff, RPMs, that's definitely going to be something that you're familiar with. Okay, other things that we have going on is radians per unit of time and degrees per unit of time, right? We just got done talking about radians and degrees, dealing with all those. Down below here, you see circumference listed multiple times. So circumference is pi times the diameter, or 2 times pi times the radius, right? Because 2 times the radius is going to give me the diameter, so they kind of fit. So if you remember the diameter times pi, we can get there regardless of what information you have. The other circumference is talking about one revolution of a circle. So if we go around one time, right, that is the circumference, right? So kind of they go together that way. And one revolution of a circle is 360 degrees, or in radians, it's 2 pi. All right, that's why we use pi radians equals 180. So if we're getting a few of these things down, we can make some translations to what we need to do. All right, so we're going to take factor label and we're going to do a whole bunch of it. All right, so the key here is we're always going to identify with what you're given. So you have to start with your given. And what we're going to do is we're simply going to step our way to the result. Okay, now that's not anything profound. I don't even know why I wrote it down. I don't know. Either way. But a lot of times you kind of get these and everything's kind of right in front of your face, but you're like, well, what do I do with it? What am I going to do? Well, they gave you something, and then that's what we're going to work with. Okay, so here's what we're going to work with. A car with a wheel diameter of 15 inches is traveling at 35 miles per hour. Find the angular velocity in RPMs of the wheel. Okay, so this is what we need to end up in, is revolutions per minute of the wheel. Okay, and then find the angular velocity in radians and also in degrees. But notice what we're going to do is we're going to end up in minutes. And right now I'm at 35 miles per hour. Okay, so that gives me a starting point, 35 miles per hour. And I know I want to change that into minutes. So that's one thing that, regardless of if I get lost in the process, that's definitely something that I can handle, right? Start with something I was given, 35 miles per hour. Okay, so let's extend that out. And what I'm going to do is say, okay, well, 1 hour is going to be 60 minutes. So that's going to kind of take care of this whole thing, right? Because now what I've done is I've gotten rid of the hour section here. So I have miles per minute. So I'm off to a pretty good start, I think. Okay, next thing I want to think about is if I want to get to revolutions, then that means I need to get away from this whole thing idea of miles, right? Because revolutions, the way we deal with that is going to be eventually in inches or radians or something in there. So I got to start changing out my miles. So I know 1 mile is going to be 5,280 feet. Okay, but I don't want feet either because I need a revolution. That's not going to be in feet. So my feet, so 1 foot is going to be 12 inches. Okay, so I'm trying to break down this miles, right? So this is kind of the process of the next thing I'm looking for is to get rid of these miles. Next thing I'm going to go do is get rid of feet. Okay, so now I have it down into inches, but what we know is the other part. Now, why am I trying to get to inches? Because we're talking about 15 inches is the diameter. Okay, so that's why I want to get from miles to inches. So what's the last part we need here? Last part we need is 1 revolution is going to be the same as 15 pi, the circumference, inches. Okay, so that's going to go ahead and take care of my inches as well now as I work through everything. All right, now for this, we're going to work everything the whole way down to a decimal to get rid of those. So let me just double check that I get rid of all of my units, right? Miles, miles, hours, hours, feet, feet, inches, inches. So now what I have left, the things that, we should be pretty happy about is I have a label of revolutions per minute, which should give me an RPM. Right? So that's what we wanted. So it's really just a huge mess of factor label. All right, now what I would probably do is just go ahead and multiply everything along the top, get a number, multiply everything along the bottom, including pi this time, get a number, and then go ahead and divide those. And when you do that, we're going to get 784.32 RPMs. All right, so that's how many times the wheel is going to spin per minute at 35 miles an hour because the diameter of the wheel is 15 inches. Okay, so if you put like a little chalk mark on there and you drove it at 35 miles an hour, that chalk mark would eventually make its way back down to the ground 784 times in a minute. That's pretty impressive, I guess, if you looked at it that way. All right, so let's take a look here. Next thing we want to do is let's get RPMs into radians. Okay, so here we go. We got 784.32, and it's going to be revolutions, and that's in a minute. And what we'd like to change that out to is radians. Okay, so let's see here, radians per minute. That's going to be 2 pi radians equals 1 revolution, right? Because I have to find a way to get rid of these revolutions. Okay, remember we had this up top here is circumference. Has multiple meanings here, right? 1 revolution, 2 pi r. All right, so here's what we have is I'm going to get rid of revolutions this time. So again, let me change these out. So this is going to be radians per minute. Hey, and that's what I'm supposed to be in, right? Radians per minute. So let's go ahead and do some calculations. We're going to multiply by 2 and pi. Right? This was over 1 minute, so nothing going on there. So we're going to double the 784 and multiply by pi. We should be at 4,928.03, and this is radians per minute as requested, right, as our second thing that we want to take care of. All right, now I'm going to go back to this 784.32 revolutions per minute. Right? And we're also supposed to get this in degrees. Okay, so the last thing we're going to do is, remember, we want to get degrees. I want to get rid of revolutions. So 1 revolution is going to be equal to 360 degrees. Again, this isn't something that's hidden here. It's all listed up here. 1 revolution, 2 pi radians, or 360 degrees. So based on what we're supposed to have it into, so this time we're going to multiply, instead of by 2 pi, we're going to take that 784, multiplied by 360. Okay. Oh, this is a big one. Here we go. 282,355.5 degrees. Okay, so we have degrees, we have radians per minute, and we have revolutions per minute. Okay, so all pretty good stuff. All pretty good stuff. All right, so we have one that you can try out here. And what I'll do is I'm just going to jot some answers on the side here. And if you can get those to match up, then that's a good thing. If not, then kind of revisit the first one and see where we have things that are the same, things that are different. Okay, so your RPMs should come out to 252.10. Okay, your radians per minute are going to come out to 1,584. And your degrees per minute are going to be 90,756 degrees. Okay, so this wheel of a bicycle, 12 inches, traveling 18 miles an hour. All right, so we're getting RPMs, radians, and degrees. Right, so it should be very much just like the last one. Try to give you plenty of space in here as well. All right, so give that a pause, give that a try. And now you're back. Okay, so here's what's going to happen with the next one. Hopefully at this point, you've all at least tried to ride a bike sometime in your lifetime. You know, that was one of the silver linings of my little guy during all our quarantine time. He was able to learn how to ride his bike because what else were we going to do? All right, so let's see what we have. A wheel. So this is kind of like the back spokes on the bike here. So it has a smaller diameter than the front. There's a belt attaching the two wheels, 3-inch, 8-inch. Okay. If the 3-inch wheel has an angular velocity of 48 RPMs, okay, so that's going to be something that I know, right? 48 revolutions, and that's per 1 minute. All right, so I don't know what I'm going to do with it yet, but I know that's something that I was given, right? And that's kind of the key here is you're given something, and let's figure out what we want to know in the end. Find the angular velocity of the larger wheel. Okay, so let's find out what's going on here. So what I need to know, kind of like the whole secret here, is I want to know how fast it's really going, right? Because here's the deal: is if you're pedaling your bike, even though these have different revolutions, they're all in the same speed. So all three of these things here listed, right? The small wheel, this belt, and this big wheel, they all have the same speed. That part's going to be consistent. They won't have the same number of revolutions per minute, but they're all going to be going the same speed. So what we're really trying to do is find a speed, and that's what we're after. Okay, so that's what we're trying to do. We're working through linear velocity to be able to get these final calculations. So let's go ahead. Let's get rid of the revolution. So one revolution. Okay, so what's one revolution equal to? Well, it's 2 pi times the radius, which is 3. Okay. But we don't really want to be in kind of no man's land here. We're trying to figure out something per minute. What I want to do is translate that. Okay, so, but what's the one revolution of the larger wheel? So one revolution of the larger wheel is going to be 2 pi times the radius of 8 in inches. Okay, so what we're going to do is we're going to translate the 48 revolutions from the small wheel to the large wheel so we can figure out how many revolutions of the radius of 8 is going to be. So that's what we're really after here. So translate the whole thing over. All right, so let's figure it out. What's nice here is things are going to cancel out. So 2 pi and 2 pi. I can reduce the 48 and the 8 if I want to. So that's going to get us down to 18 right away. Okay, again, if the numbers weren't very nice, I would just go right across the top. Right, I'm eventually going to get rid of all sorts of things. I ended up back in revolutions, and we're going to stay per minute because we want to stay in minutes. So that's kind of a nice thing. And here we're still getting rid of inches. Okay, so I think I crossed out everything we can. So revolutions per minute, and we did the calculations. It's 18 revolutions per minute for the radius of 8. Okay, so that's our larger wheel, and that's what we're after. So it's more about the conceptual of how do I change one into the other and dealing with that linear velocity. All right, last one we have for you. We'll mix this one up just a little bit. All right, so let's see what we got. What are they saying? A weight is attached to a circular drum with radius. All right, so I have a radius equals 8. Right. I'll pull that stuff out because I might need that somewhere. All right, next thing you know is the weight is going to be raised 1 foot in 5 seconds. So that is definitely something I can start with. 1 foot for every 5 seconds. And a couple things we want to deal with now is find the angular velocity of the drum in RPMs. And so that means I want to get the seconds into minutes. So that's one thing for sure. So that means I have 60 seconds, right? They're opposite of each other every 1 minute. All right, so that's going to take care of time. All right, the next thing we're going to do is change out the measure, right? Because I'm in feet, and I have to get into angular velocity into inches, right? Because we're talking about inches. All right, so 1 foot is going to be 12 inches. Right. And then we don't want to be in inches at all then, because what we want to do is change this out to a revolution. So what's one revolution based on our inches here? And that's going to be 2 pi, and the radius, right? This was given a radius of 8. So we can cross out our inches, we can cross out our feet, we can cross out our seconds. Okay, so we're going to eventually be in revolutions per minute. And what we'll find here, after a little calculation, again, we're going to go straight to decimals here. So everything across the top, everything across the bottom, and then divide them 2.86 RPMs. All right, then we want to put it in radians per minute. Radians per minute. So let's take our 2.86. 2.86 revolutions per 1 minute. And we want radians per minute, so I'm not going to change the minute, the times at all. So I just have to do 1 revolution. I have to get rid of that, and that's going to be 2 pi radians. All right, so we're going to double it, multiply by pi, and it comes out somewhere around 18 radians per minute. All right, so that's what we got for you today. This one, you really have to start taking some time and really understand what we're doing with it. It's not going to be like, all right, I watched the video and now I'm ready to go. You're going to have to really take a little bit of time with our conversions and to remember what we're trying to change things into, right? Circumference, because it has multiple meanings here, and then revolutions, and it does label itself a little bit further back into what we have been working on so far in the chapter. All right, so give it some time, and it will take time. Okay, so don't stress about it just because we got done with the video and you're like, my answer didn't match. All right, we'll keep working on it. I promise.